Okay, in this class, I will explain about another method of nonlinear programming, unconstrained optimization of minimizing a single variable function f of x. This method is called as golden section method. This method is based on a ratio called golden ratio gamma, which is given by 1.618. So it is nothing but the ratio of a rectangle, that is the dimensions of a rectangle like this, d divided by b, which is also equal to d plus b by d. So in Euclid's geometry, this rectangle with this ratio has some unique properties. That is why the ratio is called as golden ratio, and this ratio is used in this method. That is why it is called as golden section method. So this value is used here. Now in this method we are minimizing a function, given function f of x in the interval a0 b0. So a0 is the lower limit and b0 is the upper limit. So that means in our earlier method, Fibonacci method also, so we are doing the same thing. So if f of x is this and if x is this, so your a0 will be here and b0 will be here. This is the initial values of upper and lower limit values of x. So within this we have to find out the value of x for which the function f of x is minimum. So this is what we are going to do, and for this we are going to have some values in between a0 and b0, and we are reducing this range or the interval by certain criteria. So just what we did in the case of Fibonacci method, there we used the concept of Fibonacci numbers, but here we are using the concept of golden ratio. Now we are going to have two important relations here. The values of a0 and b0 are modified in the form of iterations by using this relation. So first iteration we are going to take as a1 is equal to a0 plus rho into b0 minus a0, and b1 is equal to a0 plus 1 minus rho into b0 minus a0, where rho is this constant value. So rho is given by, so this you have to remember. Of course there is a theory behind this. Let us not worry about that theory. There is a constant. Rho is a constant. 3 minus root 5 divided by 2, which is 0.382, and 1 minus rho will be 1 minus 0.382, which is 0.618. So in these places, for rho we are going to take 0.382, and for 1 minus rho we are going to take 0.618. And of course this a0, b0 values, they are nothing but the upper limit and lower limit of the given function. So that we are going to reduce this given range in the beginning, a0, b0. We are going to reduce that, and we are minimizing the bandwidth. And at some point, if within this range, we will be having a value of x for which the f of x value is minimum. Now let us take up a problem. Minimize f of x is equal to x power 4 minus 14x cube plus 60x square minus 70x. It is an algebraic function of fourth degree in the range 0, 2. So that means this becomes your a0 and b0. Locate the value of x to within a range of 0.3. So the meaning of that is, finally after some iterations, we are going to get two values of x. Two values of x like this. So these two values of x1, maybe x1 and x2, the difference between these two values should be less than 0.3. That is the meaning of that. That difference we are going to take it as epsilon. So this 0.3 is taken as epsilon here. So epsilon is the difference between the values of x1 and x2 as we reduce the range here. Finally at some stage after certain iterations, so the difference in the values x2 minus x1 value should be less than 0.3. So till that we have to do the iteration. Once you get the value less than 0.3, so you can stop at that stage. So normally apart from maybe some 3, 4, 5 iterations you may have to do using these relations. Now let us see for this problem how we are going to solve. So the f of x function is given here, x power 4 minus 14x cube plus 6x square minus 7x is your f of x. Then range is 0, 2, a0 is 0, b0 is 2 and epsilon is 0.3. So that is what is given in this problem. So let us say now the procedure is to reduce the range, 0 to 2 has to be reduced and we have to narrow the range, and finally after some iterations the difference between the two values of x will be less than 0.3. At that iteration we have to stop the process, and whatever value of function we are going to get, that will be taken as the minimum value of the function. Now the first iteration I will take up. So in the first iteration I am going to use this a1, these two equations I am going to use. So in those two equations, let us substitute the values of a0 and b0 and rho. Rho is 0.382 I have given here, and 1 minus rho is 0.618. a0 is 0, b0 is 2. If you substitute those values, you are going to get a1 value as 0.764 and b1 value as 1.236. You can see that now that range is narrowed. So 0 to 2 has become now 0.764 to 1.236. So we are narrowing the range. So initial range was 2 minus 0, that is 0, that is 2. Now the next range is 1.236 minus 0.764, it is less than 2 now. Now we will evaluate the values of that function f of x at these two values of a1 and b1. That means we are finding f of a1 by putting x is equal to a1, that is 0.764 in this function. Like this, we are going to get minus 24.86 after simplification. Then f of b1 by putting x is equal to b1, that is 1.236 in the same function, and simplifying we are going to get minus 18.96. So out of these two, the higher value is minus 18.96 because it is negative. So this is the higher value, this is the lower value. Now we are going to eliminate this higher value. Minus 18.92 we are going to eliminate, only this we will consider, and corresponding to that higher value, the value of b1 is 1.236. So this we are going to mark. Now the next interval becomes, that means here f of b1 is greater than f of a1 because it is negative. So when it is negative, the lower magnitude will be higher than the higher magnitude. So now the next interval, now we have to, now that the initial interval was a0 b0, now the interval has been reduced now. Now the next interval becomes a0 and b1. So a0 and b1. So because this b1 contains the maximum value, so what we have to do here is keep this in mind. So since we are going to take this b1 as the maximum value, so whatever a0 is there, that we will take as usual, and instead of b0 we are going to take b1. So a0 b1 is the next range. So the difference between these two, 1.236 minus 0 is 1.236 only. Anyway, this is we have to do integration till we get this value less than 0.3. But here we are getting 1.236 as the difference, which is greater than 0.3. Epsilon is 0.3 here. So therefore, we have to move still further. Now what we do is in the next iteration, instead of taking a0 b0, we are going to take a0 b1. a0 b1 as the interval, and we are going to take the next set of numbers, that is a2 b2. New values of x, second set for the second iteration. a2 is now taken, and now we are going to consider this interval. So a0 will be same plus rho into, instead of b0 b1 is there, so b1 minus a0. The same equations we are using, but these things will change now. So that becomes b1 minus a0. If you substitute that and simplify, you get 0.472 as the value of a2, and b2 is a0 plus 1 minus rho into, instead of b0 you are going to get b1 minus a0. Once again, if you substitute and simplify, you get 0.764. Now at those values of a2 and b2, find out the values of the given functions. So by putting x is equal to a2, that is 0.472 in this, you are going to get minus 21.1 after simplification, and by putting x is equal to 0.764 in this, we are going to get the f of b2 as minus 24.36. Once again, you have to proceed in the same lines. So So among these two, the higher value is minus 21.1 because it is negative. This is the higher value, and corresponding to that is A2. This is for the value of A2. So this is considered. Now that means your f of A2 is greater than f of B2. Therefore, the next interval becomes this value. I have to take now 0.472, and that means only A will be changed, B will not be changed. Okay? So this B1 remains same. So B1 remains same. So A naught becomes A2 now. So this becomes the next interval. So take the difference between these two. 1.236 minus 0.472, which is 0.764. Once again, it is greater than 0.3. So we have to do this equation till we get less than 0.3. So anyway, you can see that the value is reduced a little bit here. And so this difference value is reduced now. That means we are narrowing the range of the interval. So now after this, next third iteration we have to do for this range now. For this range. So once again we are going to calculate another two values of x a3, b3, third iteration. So a3, b3 will be, now I have to use this one now. So the same formula holds good. This is for a0, b0. So whatever we get here, for that we are going to use that formula. So instead of a0 I have to take a2 plus rho into b1 minus b2. So that gives the value of a3, 0.764 we are getting. Next, b3 value a2 plus 1 minus rho into same thing b1 minus a2. If you simplify, simply we get 0.944. Now once again for these two values of a3 and b3, we are going to calculate f of a3 and f of b3 by putting x is equal to 0.764 in this f of x. We are going to get f of a3 and that is minus 24.36. And by putting x is equal to b3, that is 0.944 in the same expression, we are going to get f of b3 as minus 23.595. Now once again among these two, this is the maximum value, higher value. So corresponding to that, the value of b3 is higher. So the next interval we have to fix the next interval. So f of b3 is greater than f of a3. So next interval is fixed as, so since here b3 I am going to take, so a2 remains same, but instead of this b1, b3 will come. So this is the interval 0.472 0.944. The difference between these two is 0.472. Once again it is greater than 0.3. Epsilon is 0.3. So still one more iteration we have to do. That is the meaning of it. So fourth iteration we have to do for this range. Now this becomes a0, this becomes b0. Now that means a4, fourth iteration is a2. So this is a2 plus rho times b3 minus a2, and b4 is a2 plus 1 minus rho times b3 minus a2. By substituting values and simplifying, we are getting a4 as 0.652 and b4 as 0.764. Now you can see here f of a4. For those two values, if you calculate the function value by putting x is equal to 0.652 in this expression, we are going to get f of a4, which we are getting minus 23.833, and by putting x is equal to 0.764, of course we are getting the 0.764 already we have got here, that is a1 value. So we are going to get the same value minus 24.86. Now among these two, higher value is this. Corresponding to this, the x value is a4, this value. Now that means, so what you can infer here is f of a4 is greater than f of b4. That means finally this b4 is there, that becomes your final value, that is the minimum value. So this becomes the minimum value, and in this problem you can observe that this b4 and a1 they are same. You can see here a1 is also 0.764, b4 is also 0.764. That means it is converging. The range has been converted to a single point, that is 0.764. So at x is equal to 0.764, you are getting the minimum value of that function, which is equal to minus 24.86. Slight variation in decimals you may get when you are calculating using calculator, no problem. So you can stop at this stage. If you observe the difference between these two, That is the range of these two. 0.944 minus 0.652 is 0.292, which is definitely less than 0.3. Definitely less than 0.3. That means we can stop at that stage, because he has given here the value of x should be located within a range of 0.3. So now we can stop at this stage, and the value of x we are getting here is 0.762, 764. Corresponding value of minimum value of f of x is minus 24.86. So this is how, this is called as the golden section method. So you don't worry about the theory behind it. So this is the procedure. So some values you have to remember. This rho value you have to remember. Once you remember this rho value, 1 minus 2 can easily calculate, and these two expressions you have to remember, and we are narrowing the range. That is very important. Even in the Fibonacci method also we are narrowing the range by what we are using the Fibonacci numbers there. Here we are using the golden ratio. And of course at the end you need not to check the answer, but for your reference I am telling the examination you need not do this, but for your reference how to check the minimum value. So y is equal to f of x is the given function. The necessary condition for minimum or maximum value of a function is f of x is equal, that first derivative should be 0. So y dash dy by dx. So if you take the derivative of this, it is 4x minus 42 x square plus 120x minus 70. It should be equal to 0. That is the necessary condition. Now by equating to 0, you can solve this equation. You will get three values of it because it is the equation. So one value 5.957, second value 0.781, third value 3.762. Now we have to calculate the second derivative value, d square by dx square, and these three values of x. So d square by y by dx square is second derivative of this, which if you differentiate this, you will get 12x square minus 84x plus 120. So if you go on putting the values of x here, for those three values of x, these are the corresponding values of second derivative, d square by dx square or dx square values. So when x is equal to 5.957, second derivative value is 45.44, which is greater than 0. When x is equal to 0.781, its value is 61.715, once again it is greater than 0 positive. And when x is equal to 3.762, you are going to get a negative value, minus 26.17, so negative value are getting. But we know that the sufficient condition to have the maximum and minimum values of the function is, so necessary condition is dy by dx is equal to 0. Sufficient condition is if d square y by dx square is negative, then you are going to get the maximum value of the function. If d square y by dx square is positive, we are going to get the minimum value of the function. Here if you observe, there are two positive values here. So d square by dx square is positive are two values of x. Among those two, the higher value is 61.715 and x is equal to 0.8781. So that means that value we have to take. That means the function has got a minimum value at x is equal to 0.781. But by using the golden section method, we have got x is equal to 0.764. Slightly, the approximate difference will be there. So this is the check we can have. Among the three, you have this value x is equal to 0.781 gives the minimum value of the function. So I have explained about global minimum and local minimum, global maximum, local maximum. The earlier lecture we can go through that. So this is an example. So we can check the answer by this method. Okay. So necessary condition, first derivative should be 0. Sufficient condition, second derivative, if it is positive, we get minimum value of the function. Second derivative, if it is negative, we are going to get the maximum value of the function. If you are getting two positive values, the higher of them we have to consider, and the corresponding value of x has to be taken taken into account. This is the method.